Here's an example of modeling with functions. All right, here's our first example. I did take this from your text, so we'll just go ahead and follow along. You're choosing between two texting plans. Plan A has a monthly fee of $20 with a $5 per charge on your per text. Plan B has a monthly fee of $5 with a charge of $10 or 10 cents per text. And so we want to express each of these plans as a function. So part A, we'll do it as a function, part B as a function. All right. So here is our solution. So the book does do a great job explaining out how to write a function. So f of x, so if you think of y equals mx plus b, that is your slope-intercept form. This is your starting point, your b, your y-intercept, and m is your continuous rate of change, your slope. This is a linear function. So you can also write it like this, f of x equals m of x plus b. And that's what they're doing here. Here is your function equal to the original amount, 20, plus 0.50 times x. So if you simplify that function, f of x equals 0.05x plus 20, written in slope-intercept form. X is going to represent the number of text messages. F of x will represent how much do you pay per month. All right, part B, very similar in the part A. Remember that is $5 of the original amount and then 10 cents per time you text. So very similar equation in slope-intercept form, y equals mx plus b. Your b is your original $5, your continuous rate of change is 10 cents, and then the number of text messages is x. So when you write that as a function, g of x equals 0.10x plus 5, and where x is going to represent your amount of text messages, g of x is going to represent your total cost. All right, so what we do have are two functions in slope-intercept form. So I have y equals 0.05x plus 20. So if we think about this graphically, your y-intercept is, let's say, up here at 20. Looks like that. All right, then you have another one, y equals 0.10x plus 5. So here is your $5, and then again has a steeper slope. What we want to find out is where is that point of intersection? So part C, we're interested in finding out how many text messages X result in the same monthly cost. So that's our part C. Where do they have the same monthly cost? So where are they going to intersect? Right there. What is that X, Y point? For the two plans, they must set the equations for f of x and g of x equal each other and then solve them resulting. So, if you remember back to Algebra 2, when you solve equations, you can set them equal to each other. So here's plan A equal to plan B. A nice linear equation, you solve by undoing. You get x equals 300. So what that means is on the x-axis over here, here's 300. So at 300 text messages, there's some cost, y, that they'll be the same value. Okay, and to find out what is that y, we substitute, here's my y equals 20 plus 0.50x. We know the x is 300. We can just substitute 300 in for x. And we simplify that and we get 20 plus 15 gives us 35. So what that says is the cost is $35 right up here. That's our y right there, $35. If you use the other equation, the y equals 5 plus 0.10x, and you substitute in the 300 in text messages. 5 plus 0.10 times 300. You get 5 plus 30 gives you 35. All right, so wrap up this problem algebraically is the cost would be $35 and the amount will be 300 text messages. All right, really cool thing about the graphing calculator in this textbook is they do show you this algebra graphically. So I did a really messy looking graph on that previous slide. Here's your one equation, here's your other equation graphed out, here's your point of intersection. And I can teach you in class, if you'd like, how to calculate this point of intersection with the graphing calculators. So you're going to get some x and y values, which we did it algebraically as 300, 35. So 300 text messages, $35, and that's where they intersect, where they'll be the same exact cost. So pretty cool there.